Okay, so we're doing 6.3 and we're going to do 13, 14, 15, and 16. And these are a lot of like draw the triangle, use sine, cosine, and tangent, or Pythagorean theorem. So if you are practicing sine, cosine, and tangent, all you're going to be doing over and over again is looking at this. So I think I started this problem a while back. So it says a kite is aloft at the end of a 1,500-foot string that makes an angle of 43 degrees with the ground. So this is my picture. I'm going to tell you right now, if you don't draw the picture, this is where a lot of students mess up. And I specifically remember my teacher telling me, he's like, draw a diagram. And he was from Boston. So he'd always be like, draw a diagram, like in his accent. And I can't think of it right now for some reason. But he would always say, draw a picture, draw a picture. If you like, if anything, draw the picture. So if you're not drawing your picture, this is probably why you're having a hard time understanding how to do these types of problems. So I'm just going to go over a couple things. Number one, I knew that the kite string is the hypotenuse because it says the string makes an angle of 43 degrees with the ground, right? So if you draw that picture and then it's going to ask you for part B, what's the height of that kite, right? So here, you're pretty much done after you set up this triangle, because then now you're looking at it and you're like, oh, I can't use Pythagorean theorem. And then you're like, oh, can I use so, ka, or toa? So which one should I use, so, ka, or toa? Yeah, sine. So I'm going to go sine of 43 degrees. Very good. Equals to h over 1,500. Right? And then you solve, and then so you get h is equal to 1,500 sine of 43 degrees. And then I'm just going to plug that into my calculator, and I'm pretty much done. I think it's already in, yeah, it's still in degrees from earlier. So let me just get rid of some of these stuff. And let me scoot this guy over. So here I'll put 1,500 sine 43, and I get 1,022. Oh, I'm just going to go 1,023. So 1,023 feet. And then I'm going to put that here and see if that triangle kind of like makes sense, right? And to me, it does, because if that string is 1,500 feet long, and then the height is about is 1,023 feet, that kind of makes sense. It's really, really high, but with that angle of elevation, that kind of makes sense. Any questions on that one? Okay. All right, number 2. It says a ladder leans against a building. The top of the ladder reaches a point on the building that is 12 feet above the ground. The foot of the ladder is 4 feet from the building. So find to the nearest degree the angle that the ladder makes with the ground. Okay, so again, here's my building. This is my building. I don't know. I'm just going to draw the side of the building. And then the top of the ladder reaches a point that's 12 feet above. So here's my ladder like this. And this right here is 12 feet. And then it says this is 4 feet. You could assume that this is a right triangle, right? Because the buildings are usually perpendicular to the floor. So there's my picture. It says find to the nearest degree the measure of the angle the ladder makes with the level ground. They're looking for this angle in here. I'm going to call them theta. Okay. So they're looking for that angle in there. And so, okay. So then what do I do? How do I do this? So clearly, because they want an angle, I'm going to use sine, cosine, or tangent. Which one shall I use? Sine, cosine, or tangent for this one? Yeah, very good. I'm going to be using tangent for this one. Why, Miss Johnson? Because it's opposite over hypotenuse. Opposite over adjacent, which in this case, that's 12 feet over 4 feet. And that's 3 feet, right? So then I'd ask, okay, how do you get theta out of tan? How do you get theta out of tan? Yeah, you inverse it. So then I go tangent inverse here, tangent inverse here, and I'll just squeeze him in there, right? So then I get theta is equal to tan inverse of 3, right? So then I bring my calculator back and I go tangent inverse. So that's this guy of 3. And so it's about, it says, wait, they want me to round to the what? Nearest what? Nearest degree. Okay, so this is going to be 72 degrees. So theta is about 72 degrees. And then before you do that, like put in there, does that actually make sense? And to me it does, because like if you think about like the closer I put that ladder to the base of the building, the bigger the angle is. Okay. The bigger the angle is. And so that's pretty close. It's 4 feet compared to 12 feet. So yeah, this kind of makes sense to me. Okay. Next one. It says the shadow of a flagpole. So this is the one I'm gonna pause. I'm gonna make you guys draw it. So the shadow of a flagpole is 40.6 meters long. The shadow of a flagpole is 40.6 meters long when the angle of elevation of the sun is 34.6 degrees. Draw your picture. Okay. So drawing this picture, you're going to draw a pole, you're going to draw the shadow, and then you're going to have kind of looking like a right triangle. And so the angle of elevation is from horizontal up. Horizontal and up. So go ahead and try that really quick. I'm going to let you guys try that. And then once you have your triangle, then label your triangle and figure out which one you're using, sine, cosine, or tangent, and then check your answer. Okay, so angle of elevation is always a little bit tricky, so I want to make sure that you guys understand. So first, I draw my cute little flag pole, which doesn't look really cute. It's just, I'm not even going to draw a flag because, I don't know, the sun is setting. I don't know, I'm just kidding. Okay, so there's your flag. Here's my, let's see, here's my shadow. Here's my shadow. I don't know what this is. Oh, wait, it goes away. Why did we just do that? It disappears. What is this called? I don't know. I need a gray. I don't have a gray. We're going to have a blue shadow, y'all. Here is my shadow. The shadow is 40 meters long. I don't know. I don't know what 40 meters is. Let's just pretend it's there. Good. Okay. And then, so if you connect the top of the flagpole to the end of the shadow, so look something like this, right? Okay. Not perfect, but just pretend, right? This angle right here is your 34.6 degrees. 34.6 degrees. That's your angle of elevation. Angle of elevation is always horizontal going up. That's why they are saying elevation, because you're going up. And then angle of depression is horizontal looking down. So angle of elevation, this guy here is like with the horizontal and looking up, right? Angle of elevation. So you're going up. Angle of depression is like if you're looking down. So maybe you're in the balcony. So here's your angle of depression. So maybe you're in a balcony. This is a balcony. This is Miss Johnson's great drawings, okay? Like no joke. Okay. So then your angle of depression always looks like this. So it like here's the horizon, right? And then you're looking down. I don't know, maybe there's like a there's like a food place here. We're always talking about food, so why not? So this is a food place here, right? So you're looking at the food place. So this is called an angle of depression because you're looking at horizon going down. Does that make sense? The angle of depression is looking down. Okay, so back to this. Sketch the picture. Perfect. Done. Label your diagram. Where does the 40.6 go? Where's the 40.6 go? Yeah, it's your shadow, right? So 40.6. I just noticed this word, this monominominatum. I don't know what that means. That's one too. Okay, so random 40.6 meters. They want to know what the height of the flagpole is. So which one would you use? Um which function would you use? Yeah, very good. I would use tangent as well. Someone said cosine. Not cosine in this case because we don't know how long this thing is. I don't know how long the hypotenuse is. Right? You can make assumptions. Most flagpoles are perpendicular to the ground, in case you didn't know that. So again, I'm going to go with tangent of 34.6 degrees equals to h over 40.6. And then multiply that as h is equal to 40.6 tan 34.6, right? Bring in my calculator here. So we got what? 40.6 tangent of 34.6 degrees. I think you're already in degrees. Yeah, I'm right. So then it's 28, right? It's 28 meters. Does that actually make sense? Does it make sense for this flagpole to be 28 meters? And it kind of does, right? It kind of does. So there's 15. Last but not least is 16. It says the angle of depression. So I'm going to make you draw this again. The angle of depression from the top of the building to a car parked in a parking lot is 32.5 degrees. So the building is 252 meters high. Draw your building. Okay, so be very careful with this one because there's a little thing that you have to make sense of it. So drawing a picture here is definitely worth it. So I'm going to give you a couple seconds to figure this out, and then I will show you. Okay, so angle of depression, right? So again, for some reason, you're at the top of a building. Okay, so the top of the building here. And you can assume because oh wow, my building is not perpendicular to the floor. Can you pretend that my building is perpendicular? So the angle of depression again is this imaginary line that's horizontal or parallel to the floor, and it goes down right here to this like this, right? So this right here is 32.5 degrees. Okay. So and then here's the car again, Miss Johnson. She's fantastic at driving cars. That's the best car I got. I mean, if I drew anything else, would you be surprised? It could also be a shoe. Just kidding. It's a car. So here's your right triangle. We got 32.5 degrees is your angle of depression. 252 is the height of the building. And then they want to know how far from the top of the building is the car on, wait, how far from the top of the building is the car on the ground? So what are they asking for? How far from the top of the building is the car on the ground? Which one are they asking for? Which one are they asking for? Yeah, they're looking for the hypotenuse, which is really weird. It's a really weird measurement, but that's what they want to know. So I'm going to use h for hypotenuse. I just realized I use h for hypotenuse and h for height, so that's super confusing. I won't be doing that anymore. So if you look at your right triangle, is your right triangle labeled the way Miss Johnson would want you to label it? And the answer is no, right? Because that angle needs to be inside the triangle, not outside. So how is that angle going to help me figure out my hypotenuse? So someone said 180 minus 32.5, which would give you what? You're there, but you're not there. I will tell you. So I'm glad that you're making this mistake now. You're there, but you're not there. It kind of would work, but you got it. I think you have some of your numbers a little bit backwards. So how would you find this? What, like, how does that 32.5, does that even help you? I guess that's my first question. Does that 32.5 even help you? Yes, very good. So someone said instead of 180 minus 32.5, it's 90 minus 32.5, which I don't even know what that is. That would be 60 and then 57.5. Can someone check that? I think it's 57.5 degrees. That's my guess. Is that right? 50, 80, 7. Yeah, I think so. Yeah, okay, perfect. So that then you're done, right? But one of the things I also want you to notice, because I want you to notice these things, is because these two lines are parallel, right? You also know that this is 32.5 degrees. Okay, so your angle of depression, so can we change this to be like the car has the ability to look up at, I don't know, this, maybe you're laying down on the floor like you are like playing hide and seek with your car. I don't know, because otherwise you'd have to include your height in there. So I'm trying to get you as low to the tippy top of the building as possible. So your angle of depression is congruent to your car's angle of elevation looking up at you. Does that make sense? I'm trying to say that this angle here is congruent to this angle here. Does that make sense? And that makes sense because these two lines are parallel and then you have alternate interior angles. You can also do the same thing with the 180 minus 90 minus 57.5. You would still get 32.5. I'm just giving you alternatives to look at this. So once you know the angle of depression, it is congruent to the angle of elevation from that other object that you're looking at back up at you, right? Okay, so with that being said, there's a lot of choices here. I'm going to go with the 32.5 just in case that Miss Johnson messed up on her subtraction. And so I am going to be using sine of 32.5 degrees is equal to 252. So before I even plug this into the calculator, should this number be big or small? Should this number be big or small? Yeah, it should be pretty big because 252 is pretty big, right? So then I'm going to solve this. I'm going to multiply by h. So now I get h sine 32.5 degrees equals to 252. And I want h to be by itself. Invisible here is this multiplication symbol. So that means I'm going to divide by sine 32.5. Divide by sine 32.5. So my final answer is h is equal to 252 over sine 32.5, which is about how much? I don't know. Let's try this. So we get 252 divided by the sine of 32.5, which is 469. Did they tell me to round? No. Let's just go 469. 469 meters. Right? So that makes sense to me because if the leg is 252, then the hypotenuse has to be bigger than it. That actually still makes sense to me. For all of these problems that we did today, my biggest suggestion is drawing a picture, finding your triangle, labeling your triangle, and then using sine, cosine, and tangent to figure it out, right? So every single one of these, that's what I did. I drew my picture, I labeled my triangle, I found my answer, right? So once you're, for me, I think that for you all, when you're doing these problems, once you have your right triangle, you're like, oh, it's sine, oh, it's tangent, oh, it's cosine, for the most part. And so the problem is you getting your triangle on your paper so that you can pick which one that is. Okay. So I hope that makes sense.